Have you ever wondered how object-oriented programming works? It's a unique approach to coding that organizes software into reusable and self-contained units, which we refer to as objects. Each of these objects is a little powerhouse of its own, encapsulating data and behavior. Picture a set of building blocks, each with its distinct shape, color, and size. Now imagine being able to use these blocks over and over again to build unique structures. That's the beauty of object-oriented programming. It promotes modularity, flexibility, and maintainability. It's like having a toolbox filled with different tools, each designed to perform a specific task. The toolbox is your program, and the tools are your objects. These objects work together to create a fully functioning application. Intrigued? Well, hold on to your hats, because we're about to dive deeper into the key concepts and principles of object-oriented programming. So, what exactly is a class in object-oriented programming? Well, imagine a blueprint for a house. This blueprint contains all the information needed to construct the house, such as the number of rooms, their sizes, and where they're located. A class in object-oriented programming is much like that blueprint. It's a template for creating objects. Now, a class has two main elements: properties and methods. Properties are like the characteristics of the house, such as its color, its size, or the number of rooms it has. In the context of a class, these properties could be things like the name of a user, the age of a person, or the color of a car. On the other hand, methods are the behaviors or actions associated with the class. For example, if we consider a class named car, the methods could be start engine, stop engine, accelerate, and brake. Just like how you can do different things in different rooms of a house, an object created from a class can perform various actions defined by its methods. So if a class is a blueprint, what then is an object? An object is like the house built from the blueprint. It's a concrete instance of the class. If we have a class car, an object could be a specific car, say a red Ferrari. An object has a state and behavior. The state is defined by the current values of the object's properties. For instance, if we have a property color in our car class, the state of a specific car object could be red. The behavior of an object is defined by its methods. So, for our red Ferrari, the behaviors could include starting the engine, stopping the engine, accelerating, or braking. To summarize, a class is like a blueprint, defining the properties and methods for creating objects. An object, on the other hand, is an instance of a class, with a specific state and behavior defined by the properties and methods of its class. Now let's talk about how we can hide the internal details of these objects. Ever heard of encapsulation in programming? Well, it's a fundamental concept in object-oriented programming. Encapsulation is like a protective shield that prevents data from being accessed directly. It's all about hiding the nitty-gritty details from the outside world. This is done by bundling data or attributes and the methods that operate on that data into a single unit, an object. You can think of it as a package that safely contains all the relevant data and behaviors. By doing so, we can control how this data is accessed or modified. But how does encapsulation really work? It uses what we call access modifiers. These are the gatekeepers, deciding what gets in and what gets out. The most common types are public, private, and protected. Public methods are like open doors, allowing any code to access the object's attributes. Private methods, on the other hand, are like locked rooms, only accessible from within the object itself. Protected methods sit somewhere in between. They're accessible within the same class and its subclasses. Now let's move on to another fascinating concept: inheritance. Imagine you're creating a game with different types of characters. Instead of creating separate classes for each character, wouldn't it be easier if you could create a general character class and then make specific classes for each character type, inheriting all the common attributes and behaviors from the character class? That's what inheritance allows us to do. It's all about reusability and organization. Inheritance forms a hierarchical relationship between classes. We have a superclass or base class and a subclass or derived class. The subclass inherits properties and methods from the superclass. It can also extend or override the inherited features. This way, we can add unique properties or behaviors to different characters without rewriting the common ones. So, encapsulation and inheritance, two powerful tools in our object-oriented programming toolkit. They help to make our code more secure, maintainable, and organized. They allow us to build complex systems by using simple, reusable blocks of code. Isn't that neat? But what if objects of different classes need to be treated as objects of a common base class? Enter polymorphism. Polymorphism allows objects to take on many forms. It's a key aspect of object-oriented programming that adds a level of flexibility and dynamism to our code. In essence, polymorphism allows us to treat objects of different classes as if they're objects of a common base class. This can be achieved through two main techniques: method overloading and method overriding. Method overloading is when we define multiple methods with the same name, but different parameters within a class. Each version of the method performs a slightly different function based on the parameters it's given. On the other hand, method overriding is when a subclass provides a specific implementation of a method that is already defined in its superclass. This allows the subclass to inherit the general behavior from the superclass, but also to customize or extend this behavior as needed. With these concepts in mind, let's move on to the principles of object-oriented programming. Have you heard of the solid principles in object-oriented programming? If not, then you're in the right place to get a quick crash course. These principles are essential guidelines that help developers create efficient, maintainable, and scalable systems. Let's break them down. First up is the Single Responsibility Principle, or SRP for short. It's all about keeping things simple. A class should have only one job, one reason to change. This narrows down the focus of each class, making your code easier to manage and less prone to errors. Next, we have the Open-Closed Principle. This principle suggests that a class should be open for extension but closed for modification. In other words, you should be able to add new functions to a class without changing the existing code. It's like adding an extension to your house without knocking down walls. Then there's the Liskov substitution principle. It's a bit of a mouthful, but it's fairly straightforward. It states that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. Think of it like this. If you have a bird class and a duck class that extends the bird class, you should be able to treat the duck like any other bird and the program should still work. The fourth principle is the interface segregation principle. This principle emphasizes that a class should not be forced to implement interfaces it doesn't use. Essentially, it's about avoiding unnecessary bloating in your interfaces. Finally, we come to the dependency inversion principle. This principle advises that high-level modules should not depend on low-level modules. Instead, both should depend on abstractions. This reduces the dependency between modules, making your code more flexible and easier to refactor. These principles guide good object-oriented design, but there's more to object-oriented programming than just these. So, stick around as we continue to delve deeper into the world of object-oriented programming. Let's look at some other important concepts in object-oriented programming. Firstly, we have composition. This is a way of building complex objects by combining simpler ones. Think of it like building a house using bricks, wood, and metal. Each of these elements alone is simple, but when combined, they form a complex structure. In coding terms, each object remains independent, but they work together to create a larger, more complex object. The magic of composition lies in its ability to promote code reuse and avoid issues related to deep class hierarchies. Next up is aggregation, which is a special form of association that represents a whole-part relationship between objects. To visualize this, consider a car. A car is composed of an engine, wheels, seats, and so on. Each part is an object, but together they form the whole car. This concept allows us to build complex structures by combining simpler ones, similar to composition. Then we have association, a broad term that represents a relationship between two or more objects. This can be a simple relationship, like a student attending a school, or it can be a more complex one, like aggregation or composition. The key here is that association allows objects to communicate and interact with each other, creating more dynamic and interactive systems. Last but not least, we have delegation. This is a design pattern where an object passes a task to another object. Essentially, it's like saying, I can't do this task, but I know someone who can. By doing this, we can ensure that each object does what it's best at, enhancing code modularity and maintainability. All these concepts, composition, aggregation, association, and delegation, are essential tools in the object-oriented programming toolbox. They help us to build complex objects, establish relationships between objects, and ensure that our code is clean, efficient, and maintainable. And that's a wrap on the basics of object-oriented programming. So we've covered a lot of ground today. we've dived into the world of object-oriented programming, exploring concepts like class, object, encapsulation, and inheritance. We've also touched on polymorphism and the solid principles that guide effective OO design. Furthermore, we've discussed other important concepts like composition, aggregation, association, and delegation. All these principles and concepts aim to make our code more modular, flexible, and maintainable. Remember, object-oriented programming is all about creating reusable, self-contained units of code. Happy coding!